In this simulation, we will start with the eye looking in the distance, 0 diopters, and then looking at about 10 inches, or about minus 3.8 diopters. This is the input to the control center system, and I will review it on the schematic. Here's the input, which is what you're looking at on a 16-hour per day basis. We've idealized this by saying looking at in the distance or at about 10 inches, minus 3.8 diopters. Here's a block diagram of this system, which includes depth of focus and delay, which causes hysteresis in the system. The output then is the lens. The lens will run between 0 to minus 3.8 diopters with oscillation as previously demonstrated. Here's the circuit, and I've taken a plus and minus 4 volt signal and converted it to 0 to minus 3.8 volts to represent the input to a control system. This signal is fed down to an error detector consisting of a 10K and a 20 microfarad capacitor. This is an error detector that is fed to a deadband circuit. The deadband has a 10K and 100K. This makes the system unstable because the signal has to oscillate back and forth in order to maintain control, as you've seen in the drawings. Lastly, you have the motor amplifier, or that drives the lens of the eye through ligaments associated with the lens. In order for all this system to work, the signal must be fed back to the error detector, which continuously changes the lens to maintain accurate focus on the retina. So this is the accommodation system, which now includes hysteresis or deadband. The output is seen in a meter as oscillation and in the oscilloscope. Here is the output, which now contains the oscillation caused by deadband. It runs between 0 diopters, oscillating around 0 diopters, and then to minus 3.8 volts or 3.8 diopters, oscillates around that point. What this means is the eye is in continuous control of its refractive state, and it gets control by the accommodation signal as shown here. Lastly, here's a meter that represents the oscillation in the lens of the eye necessary to maintain accurate focus. It may seem strange that this oscillation is necessary to continuously hunt for active focus or controlling by micro blur at the surface of the retina. I hope this clarifies some of these issues. The eye is a sophisticated control system and necessarily is well built, well designed, and works in ways that we don't understand completely. Thank you.